15 animal fights, 15 titans, underdogs with no reason to win. This is the law of nature, as we have believed for centuries. Size decides the winner and the loser. But this is the animal kingdom. No referee, no rules, no mercy. Across 15 animal fight nights, one challenger provokes two of the Savanna's ultimate predators and defeats them both. Who's your pick for the showdown between underdogs and titans? Drop your answer in the comments right now and join us for the first battle. One versus 5. The calf is too young to outrun anything. The forest behind them is gray wolf territory, no escape on land. And the cow moose is carrying the physiology of winter into a summer afternoon. They've been tracking for over a kilometer without attacking. Predators don't rush. They wait for prey to make the first mistake. An outcome that seems already written, but the cow moose refuses to accept it. She moves toward the water. This isn't a flight instinct. It's learned adaptive behavior, passed down through generations of moose in Yellowstone. Experienced cow moose actively move toward water sources when gray wolves are detected, because water isn't just shelter. Water completely rewrites the equation of the fight. But to understand why water reverses that equation, you have to understand the physiological limits of a moose on dry land. The moose is the largest member of the cervidae, 450 kilograms, hollow shaft fur. Every single hair is a hollow tube, trapping air inside like invisible armor against the cold, perfect for winter. But at temperatures above freezing under intense exertion, a moose cannot run continuously for more than 15 minutes before it begins to overheat. On land in summer, gray wolves chase, exhaust, isolate. The equation tilts completely toward the predator. In water, the equation flips. The moose is the largest land animal in North America. Wide hooves, spreading like paddles in shallow water. Standing on the lake bed at belly depth, the moose has 4 solid anchor points. Gray wolves, slender legs, not built for aquatic environments, lose most of their control and drive force. A single kick from a moose generates up to 900 kilograms of force per square centimeter. Enough to take a gray wolf out of the hunt in a single strike. And in shallow water, the moose can kick in any direction, while the wolves cannot hold a stable angle of attack from any side. Moose one final advantage, one no wolf pack can anticipate. Moose routinely dive to depths of 6 meters to feed on aquatic plants, capable of holding their breath for up to 30 seconds. A feeding skill millions of years in the making, which in this moment becomes a tactic for vanishing completely from any encirclement. Gray wolves understand the risk-reward calculation better than almost any predator alive. The pack withdraws the moment risk exceeds the value of the prey. This is summer on land. The moose overheats after 15 minutes, and the calf is exhausted, an equation that favors the wolves. But the moose changed the battlefield. In the water, the advantage belongs to the underdog. The wolves know it, and they accept it. After 4 minutes of standoff, the underdog, a mother, no antlers, alone in the middle of an open lake. The titan, 5 gray wolves, perfect pack strategy. The titan chose the prey. The underdog chose the battlefield. Yellowstone is the largest proof of this principle. Since gray wolves returned in 1995, moose behavior changed completely. Not just how they run, but where they choose to feed, to rest, to breed. Predator and prey are evolutionary forces, actively shaping each other. This is the first lesson of tonight. 14 more are waiting ahead. But the next underdog has no battlefield to choose. It cannot move toward the water, cannot change the terrain. So when you cannot run, how does an underdog fight? Kruger National Park, South Africa. A creature that doesn't fear venom. A venomous snake is easy prey for this animal. Each one 4 to 5 times the honey badger's weight. They can smell food from half a kilometer away. Across Kruger and across the entire continent, spotted hyena ranks second only to the male lion. A honey badger that hunts venomous snakes weighs just 12 kilograms, not worth a second thought. But the honey badger doesn't see it that way. The honey badger has all the confidence it needs to provoke hyenas. Honey badger anal glands are more potent than a skunk's, deployed within a 6-meter radius. It triggers an involuntary withdrawal reflex, even when the hyena is physically capable of continuing. In combat, this is a formation-breaking mechanism, enough to create distance, enough to counterattack, enough to collapse pack coordination. Honey badger skin is 6 millimeters thick, thicker than Cape buffalo hide. But thickness isn't what matters most. The architecture underneath does. The skin isn't anchored tightly to the body beneath. A thick, flexible connective tissue layer lets it slide independently from muscle and bone. Beyond that, the honey badger carries a mutation in its acetylcholine receptor protein, the exact receptor that alpha neurotoxin snake venom targets. The mutation drastically reduces venom-binding efficacy. All 3 layers operate independently and simultaneously. No single hyena tactic can break all 3 at once. Spotted hyenas are one of Africa's most successful predators, with a kill success rate higher than lions. But that success rests on one assumption. Prey will react in predictable ways. Run, cower, and when held, stay still. The honey badger does none of these things. Surrounded, it breaks formation with chemistry. Bitten, it spins 180 degrees and counterattacks. It never becomes passive. In this encounter, the hyenas recalculate, how much is this meal worth against the risk of continuing? The honey badger isn't brave in any human sense. It lacks the biochemical machinery. That makes most animals flee under threat. High adrenaline, cortisol, the stress hormone, abnormally low. High arousal, no fear-based inhibition. But this is not the real reason why this animal cannot be destroyed. The architecture behind all three mechanisms goes deeper. When we meet the honey badger again later in this video, it will face something 15 times its size. And that's when you'll see that architecture in action. And the next underdog, a distant cousin of the honey badger, carries an attitude that makes every rival skip the meal. The Rocky Mountains in January, 60 centimeters of packed snow. Temperature, minus 18 degrees Celsius. In North America, they hold the largest territorial range per kilogram of body weight of any land carnivore on Earth. A single male wolverine controls territory up to 1,600 square kilometers, the equivalent of the state of Rhode Island. Wolverines don't hunt in packs. They share no territory. They accept no allies. But in the coldest months, territorial boundaries become something even the hungriest are willing to violate. The wolverine's anal glands release a powerful musk, extremely potent, slow to fade, binding to food in a way that cannot be erased by any Arctic wind. The resident wolverine had marked this elk carcass with a systematic logistical strategy. Eat a portion, mark the rest, cache it across multiple sites in the territory, and return in sequence. The intruder received the message, but in this scarce winter, no message is strong enough to stop a hungry wolverine. The Latin name for this species is glutton, those who consume everything and never accept a shared portion. The upper carnassial teeth of the wolverine rotate 90 degrees from the standard axis of mammalian meat-cutting teeth. This is the only land carnivore with teeth built this way. The lateral rotation is not optimal for vertical bite force, but allows horizontal grinding through the hardest materials. Frozen bone at minus 18 degrees, cartilage locked solid, and when needed, the skull of a rival. Both animals move with equal efficiency across 60 centimeters of packed snow. No size advantage, no weapons advantage, no terrain advantage. Only one variable remains: who is willing to pay a higher price? The fight erupts without mercy. Jaws lock onto the rival's skull. The wolverine's signature twisting motion, rooted in its flexible spine, can be used to dislocate a rival's limb if the grip holds long enough. The resident had already eaten before the attack. It had something the raider did not: calories enough to choose. The raider walked 1.5 kilometers at minus 18 degrees Celsius to get here. It had no plan B, so it had to gamble everything. And as fortune had it, that gamble paid off. On the Great Barrier Reef, every burrow is contested territory. The burrow's occupant is a peacock mantis shrimp, 16 centimeters long. The crab weighs 300 grams with a hard chitin shell. A clear advantage. But the peacock mantis shrimp holds its ground with full confidence. Mechanism 1. The double strike. The mantis shrimp's club arm accelerates at 10,000 G. For comparison, a heavyweight boxer's punch is roughly 100 Gs. The club tip velocity at contact is 23 meters per second. Force on an area smaller than a fingernail, 330 kilograms. But this is not the real weapon. When the mantis shrimp's club arm moves at that speed through water, pressure behind it drops below water's vaporization point, creating a void bubble that exists for only microseconds. Then collapses, releasing heat, light, and a pressure wave. Temperature inside the collapsing bubble reaches nearly 4,400 degrees Celsius. The surface of the sun is 5,500 degrees Celsius. The collapse wave delivers a second impact, half a millisecond after the initial physical strike. The crab takes 2 hits from 2 completely different mechanisms in the same single strike. Even if the punch misses entirely, the cavitation wave can stun or even kill a creature of similar size. The mantis shrimp's club arm can absorb 50,000 to 70,000 strikes, thanks to hydroxyapatite crystals that form the club, arranged in a helicoidal pattern. Materials scientists at UC Riverside spent 10 years studying this structure to apply it in developing next-generation body armor for military applications. Mantis shrimp possess 16 color channels. Humans have only 3. Yet its brain is not complex enough to distinguish 16 million distinct colors. Research from the University of Queensland revealed the mantis shrimp's visual system can process the light spectrum reflected from surfaces down to the molecular crystalline level. They no longer care about 16 million colors. Instead, before striking, mantis shrimp scan the crab's shell to identify the zone of lowest crystal density, the weakest point in the structure, and aim precisely there. The crab's shell fractures at its structural weak point. Its nervous system stunned by the double pressure wave. Crabs spent hundreds of millions of years evolving armor. Mantis shrimp spent the same time, evolving a way to break it. And the next underdog doesn't use speed to deliver its strike. It uses speed to turn the entire sky into its battlefield. 11. "390 kilometers per hour. This is the speed of the fastest predator on Earth. For millions of years of evolution, not a single bird species learned to escape that dive, except one, a bird weighing just 70 grams. The peregrine falcon is evolution's finest aeronautical achievement. Swept back, narrow wings. Where blunt wings create turbulent drag, narrow wings taper the contact edge, eliminating resistance. Folding wings fully against the body aerodynamically fuses the frame. Aerospace engineers copied this principle into aircraft wing designs starting in the 1950s. With vision 4 times sharper than human eyes, peregrine falcon can detect prey from more than a kilometer away. The peregrine falcon's dive technique has a name: the stoop. Nictitating membrane shields the eyes from wind while maintaining full vision. Cone-shaped bony structures inside the nostrils diffuse air pressure to prevent lung damage at peak velocity. But 390 kilometers per hour has one weakness: sudden sharp turns. The fastest attacker in the world is only dangerous when prey is exactly where it predicted. Peregrine falcon locks onto a starling at the flock's edge. But the starling caught the shadow. Starlings are fast flyers, and at 70 grams their size creates another advantage: wing loading significantly lower than the peregrine falcons. So it can execute a hard banking turn at a speed the falcon physically cannot match. GPS and accelerometer studies on wild urban individuals by Diego Suarez and colleagues at the University of Barcelona showed starlings perform evasive turns in under 100 milliseconds, faster than the falcon's own reaction time. Success rate when the falcon has enough observation time to plan: 82%. When forced to strike immediately by an unexpected target, drops below 20%. The fastest creature on Earth perfected speed over millions of years. But that very speed forced prey to evolve greater agility. In the 5 battles just witnessed, peregrine falcon or mantis shrimp, which one surprised you most? Leave your answer in the comments below. And now, the animal fights move into a new phase, with molecular biology, blood, venom, and skin architecture that even lion's claws cannot bring down. In Arizona, apex predator of the Sonoran desert night. Not the largest animal, not the fastest. This is the most venomous scorpion in North America. Venom enters the body. What happens next? Arizona bark scorpion venom works by binding to sodium channel NaV1.7. This is a transmembrane protein in nerve cells, responsible for transmitting pain signals to the brain. When venom locks NaV1.7, pain signals fire uncontrollably. The effect is near paralytic. The animal loses all normal function. But the grasshopper mouse carries a specific mutation in the NaV1.8 channel structure, a structural difference invisible to the eye. Instead of bypassing this channel, the venom binds NaV1.8 and locks it shut. The result: pain signals are blocked, not amplified. The scorpion's weapon, when applied to the grasshopper mouse, becomes a local anesthetic. Research from the University of Texas, Austin confirms the NaV1.8 mechanism. It remains one of the most widely cited examples of molecular ectoparasitism. It means an evolutionary mechanism in one species is exploited by another, reversing its original function entirely. Crucially, the NaV1.8 mutation is absent in grasshopper mouse populations living outside scorpion territory. This mutation evolved specifically and precisely, like a lock engineered to fit exactly one key. This is an arms race that is fundamentally asymmetric. The Titan perfects its weapon. The underdog finds the molecular blind spot within that weapon and rewires its own nervous system around it. In the Sonoran Desert at night, the apex predator weighs less than a slice of bread. Evolution doesn't need size. Evolution needs exactly one mutation. But the next underdog doesn't rewire its brain to resist the Titan. It rewires its chemistry to cook them alive. Amazon, wet season, 500,000 versus 1. No single creature in the Amazon ecosystem can survive being engulfed by an army ant column, except one bombardier beetle the size of a fingertip. What happens next? Inside the bombardier beetle's body are two separate chambers, one holding hydroquinone, one holding hydrogen peroxide, both completely harmless when kept apart. But when pumped simultaneously into a reinforced reaction chamber lined with heat-resistant proteins, a chemical reaction ignites instantly. Temperature spikes to 100 degrees Celsius in milliseconds. The boiling mixture erupts from the abdominal tip at 500 pulses per second. Each pulse is discrete, between bursts. The reaction chamber cools just enough to prevent the beetle from exploding before the next pulse fires. This is a built-in natural cooling system integrated directly into the weapon in a creature the size of a grain of rice. The nozzle rotates nearly 270 degrees, horizontally and vertically. Research by Thomas Eisner and Daniel Anna Shansley at Cornell University captured it using a camera shooting 2,000 frames per second. When an ant touches any point on the beetle's body, the spray targets that exact contact point within 1.7 milliseconds, faster than the ant can respond to thermal stimulus. This response is driven by a somatosensory neural map. Every touch point on the body surface maps directly to a corresponding spray angle, bypassing central processing entirely. The weapon isn't just powerful, it has an auto-targeting system built into the neural architecture itself. And if that still isn't enough, the beetle activates its defense mechanism from within. The predator is forced to regurgitate the beetle, alive, intact. No other prey in the Amazon ecosystem can escape from inside a predator's stomach. Blasts of superheated vapor push ants back within a 3-centimeter radius. The heat blast creates a zone at 100 degrees Celsius within a 3-centimeter radius. No ant can maintain grip inside it. The ant column doesn't scatter. But the beetle also keeps moving forward. It has sprayed enough to carve a 3-centimeter corridor through the ant column and emerge on the other side. Bombardier beetle, 0.3 grams, the size of a fingernail. No physical strength against the sheer numbers of 500,000 army ants. The Titan has no limit on numbers. The Titan has a limit on temperature. The most powerful weapon isn't the one that causes the most damage. The most powerful weapon is the one that works in every situation, even after being swallowed. The next name also uses chemistry, but its prey won't know it has already lost until 3 days later. Most predators need to overpower prey to win. The Komodo dragon chooses a third option: infect and wait. Komodo dragon, a forked tongue constantly sampling the air, has been tracking from 200 meters, 150 kilograms. A sense of smell that detects blood from 9 kilometers. Each fork of the tongue samples a separate chemical channel, creating stereo triangulation. It has been waiting for this moment. For decades, science believed the Komodo dragon subdued prey with 57 strains of lethal bacteria in its saliva. But in 2009, Brian Fry at the University of Melbourne discovered the Komodo dragon possesses complex venom glands embedded in the lower jaw. These glands secrete an anticoagulant protein blend, phospholipase A2, kallikrein, delivered directly into the wound during the bite, triggering systemic hypotension. They turn a wound that appears minor into one that bleeds without stopping for hours. A bite to the hind leg. Day 1, the buffalo still stands. Day 2, the buffalo begins separating from the herd, energy depleting, movement slowing. The dragon stays within 200 meters. Day 3, the buffalo can no longer rise. This is when the predator collects its prize. The water buffalo in its final 3 days had no idea. The outcome was sealed. The moment the dragon bit, the biochemical war continues as the underdog uses its own blood to push the titan toward an end it never chose. Back to the Sonoran Desert. Its skin blends with the desert floor, nearly invisible when still. The horned lizard is one of the few reptiles that specializes in harvester ants, among the most chemically toxic insects on the continent. It can neutralize harvester ant venom and accumulate compounds from that venom for its own defense. From the east, a coyote patrols its territory. "16 kilograms versus 30 grams, a ratio that, in almost every encounter on this continent, does not end well for the smaller animal. In the desert, animals that don't flee usually don't survive long enough to breed. Beneath the skin around the horned lizard's eyes is a structure found in no other living reptile, the ocular sinus, a blood-filled pouch just beneath the conjunctiva, connected to the main circulatory system via a small valve-controlled vein. In its resting state, the sinus is small, invisible from the outside. When threatened, The lizard contracts muscles around the neck and eye socket, restricting blood flow from the head back to the heart. Pressure builds in the circulatory system of the head. When pressure exceeds the rupture threshold of the sinus wall capillaries, blood jets from the eye socket in a directed stream that can reach 1.5 meters. The lizard can expend up to 1/3 of its total blood volume in a single defensive discharge. This is the weapon with the highest physiological cost in today's video, a resource that cannot be replenished quickly. Continuous for 0.4 seconds. The blood contains compounds that trigger immediate withdrawal reflexes in canids. In the Sonoran Desert, every coyote learns this once. None approaches again. The horned lizard survives, still has much to do today. Kalahari Desert, Southern Africa. The honey badger returns and challenges one of the savanna's greatest predators. Lions have brought down wildebeest, zebra, even buffalo. And the toughest prey they know. But nothing like the honey badger. 12 kilograms versus 185 kilograms. This position ends every fight with any other animal of this size, but not the honey badger. Its skin is 6 millimeters thick, equivalent to tire rubber, but the decisive factor is the connective tissue beneath. Honey badger skin does not adhere tightly to the muscle layer as in normal anatomy. Along the back and flanks, the skin anchors to muscle only at 2 narrow bands, along the spine and along the belly midline. This creates a hollow cavity between skin and body. When the lion bites the badger's back and lifts, it holds only skin in its jaws. Inside that skin sleeve, the body is largely free. The actual body rotates 180 degrees, no need to escape. This is not a position. The lion wants anything with teeth near. The lion's nose carries pain receptor density, nearly 10 times higher than regular skin. This is the most sensitive region on the face, unprotected by muscle or fat. A deep bite to the nose cannot fully incapacitate a lion, but it generates a pain signal intense enough to override predatory drive. Colleen Begg documented 9 complete encounters between honey badgers and lions. In each case, the outcome was the same. In all 9 recorded encounters, the lions had to leave because they could do nothing with the honey badger. 17 minutes, a 185-kilogram lion, and a 12-kilogram honey badger that does not stop. Honey badger, 12 kilograms. No hard armor, no toxic fangs, no superior speed. Male lion, 185 kilograms, apex predator of continental Africa. Hard skin shares one common limitation. It is fixed. The attacker can adjust angle, increase force, find the joint between armor plates. Loose skin creates a problem of an entirely different category. The bite point moves relative to the body beneath. The actual body never stays in the position the attacker targeted. Hard armor protects the surface. Loose skin protects the position. This is survival architecture that beats brute force. Neural mutation, chemical reaction at 100 degrees Celsius, anticoagulant proteins, blood weaponry, specialized venom, and loose skin architecture. 6 more animal fight nights. 6 ways biology shatters every assumption size makes. If this video just changed the way you see the animal world, like, comment, and subscribe. For now, the next chapter starts immediately, and the first fight is something no individual possesses, only a colony. Also in South Africa, Kruger National Park greets the dawn. With a lion pride mid-hunt. Standard predator tactics, executed flawlessly. But this is not the end. African hunters call the Cape buffalo Black Death. Unlike most herbivores, Cape buffalo actively track and attack threats, even after the threat has retreated. This behavior is extraordinarily rare among herbivores. It demands a completely different cognitive structure, not just recognizing danger, but calculating a deliberate response. Cape buffalo live in herds of dozens to hundreds. They recognize specific members by name, by call, and by scent. When one member is in danger, a distress call carries location and threat information to the individuals with the closest social bonds. A mature bull's horns form a boss structure, a dense plate of horn thickest at the forehead, unmatched in the bovine family. "40 million years co-evolving with lions on the African savanna. Not to run, but to fight back." In 2004, at Transport Dam in Kruger National Park, a group of tourists accidentally captured 8 extraordinary minutes on camera.
I need to get it down quickly. Go!
The buffalo's call carried 500 meters through dense brush. For the lion, pride, formation, and direction no longer mattered. Surviving came first.
I need to get it down quickly. Go!
The buffalo's life was saved in the nick of time. Lions never charge a large buffalo herd. Every predator tactic depends on one thing: keeping prey from acting as a single unit. When the herd restores that social connection, the lion's strategy loses all its power. Research by Karen Mosser at the University of Minnesota found lions chose to ambush herds under 15 buffalo at 4.3 times the rate of herds over 30, even when weaker prey was present. The weapon of survival is not individual strength. It is the network of social recognition and the critical threshold where the collective crosses the tipping point. But the next underdog does not fight with numbers. It fights with maternal instinct. April off the coast of Baja, California. The Pacific, cold, vast, and unmerciful. The gray whale mother is a perfect combination of 40 tons of muscle and survival experience. 20 years old, she has made this journey many times before. No natural predators. But her calf is different. 4 months old, 2,270 kilograms. Large enough to be prey, but not yet wise enough to survive. The orcapod knows this. Big's orca, specialists in marine mammal hunting, deploy in optimized formation. Knowledge passed from mother to calf through years of observation and practice, and the plan has 2 simple phases. Phase 1. Separate the calf from its mother. Orca are far more agile. Maximum swim speed 56 kilometers per hour versus 19 kilometers per hour for a gray whale. Phase 2. Hold the calf underwater. A 4-month-old calf needs to surface for air every 3 to 5 minutes. Orca can hold their breath up to 15 minutes. The predators will keep the calf submerged long enough until it never surfaces again. This technique is documented in Monterey Bay in Alaska and across the North Pacific, executed with a high success rate. But this plan is built on one assumption: the gray whale mother will stay above the surface and react in predictable ways. But experience had given the gray whale another way. To save her newborn, the calf was lifted onto her belly's surface, head above water, safe from the depths below. But the whale's blowhole sits on her back. Rolled over, her blowhole goes under. Would her solution create a different tragedy? This is maternal instinct, transcending the limits of her own physiology. Adult orca weigh 3 to 6 tons, a size that commands respect, but nothing against a struggling gray whale mother. The gray whale mother could deploy her tail, the most powerful in the animal kingdom relative to body size, to create crushing shock waves. After nearly 2 hours, the orca pod turned away, seeking easier prey elsewhere. And their 20,000-kilometer migration continued. Orca are the ocean's apex predators. The titans carry strength, intelligence, and a perfect plan for every predictable variable. But not for a mother's love. No plan was designed for a mother who refuses to breathe normally to protect her child. Now to the Ho Islands of the Antarctic Peninsula, where the battlefield is a cobblestone shore. A Gentoo penguin colony in breeding season. Gentoo penguins swim at 35 kilometers per hour, nearly 4 times the speed of an Olympic swimmer. Most predators cannot match them. But this chick cannot swim yet. The southern giant petrel is the most ferocious seabird on Earth. They hunt seal pups, attack penguins in the water, and raid Gentoo penguin colonies to steal eggs and chicks. The southern giant petrel knows the chick's weakness. Not yet able to swim, reflexes not yet formed, and most adults will not risk their own lives. Most. The first petrel had its beak in exactly the right position. And then the second petrel arrived. 2 petrels, each weighing 5 kilograms, the chicks surrounded from both sides. The father penguin did not stop to calculate. Through evolution, penguins surrendered the ability to fly, to master the ocean. Science calls their flightless wings flippers, solid paddles, perfect propellers in the water. And on land, when driven by the shoulder force of an adult Gentoo, it becomes a strike of solid bone. Petrels carry blade-like beaks and the speed advantage of aerial assault. But when the plan required them to stand on solid ground, they encountered something their instincts never prepared for: a father's love. And that, perhaps, is the one thing no force on earth can defeat. Kaeng Krachan National Park lies southwest of Bangkok, in Thailand. Breeding season. The rainforest becomes a stage for the strangest encounter in the reptile world. Each carries enough venom to kill an elephant. And then it begins. A ritual. The king cobra is the longest venomous snake on Earth. Despite its name and some similarities, it is not a true cobra in phylogenetic terms. It belongs to the genus Ophiophagus, species with a tendency to eat snakes, including other king cobras. A single king cobra bite injects enough neurotoxin to bring down an elephant within 3 hours. No reason exists why the larger king cobra should not simply bite the smaller one. So why doesn't it? In a wrestling match lasting up to 30 minutes, if an opponent's head touches the ground, it signals submission. A snake is only food when it is the right size for a meal. So, the king cobra does not waste venom, just to subdue another king cobra. Recently, the king cobra was discovered to be not one species, but 4 distinct species distributed across separate geographic ranges. The northern subspecies, across Thailand and India, is the one documented performing this ritual combat. The ritual protects both sides. The winner holds territory. The loser retreats and lives on, strong enough to find another opportunity. The larger one holds the weight advantage. With every downward press, the smaller one absorbs more pressure. Neither one opens its mouth. No threat display. The fight ends after 30 minutes, when one allows its head to touch the ground a 3rd time. The loser withdraws, still carrying enough venom to kill an elephant, still strong enough to fight another day. And finally, back to Africa, with a snake no less deadly than the king cobra. The black mamba is the fastest snake alive. Up to 15 milligrams of venom per strike, enough to kill an adult human in 20 minutes without treatment. Fatality rate, 100%. On the Savanna, the black mamba is the endpoint of nearly every food chain it enters. Except for one small creature. The mongoose's entire survival strategy starts from a single point in the amino acid sequence of the nicotinic acetylcholine receptor. This is a protein on the surface of muscle cells that receives nerve signals to trigger muscle contraction. In most mammals, alpha neurotoxins in cobra and mamba venom bind tightly to this receptor, locking it completely. This blocks nerve signals, leading to paralysis and respiratory failure. In the mongoose, a mutation at a specific amino acid position altered the shape of the receptor's binding region, enough that alpha neurotoxins can no longer attach effectively. The mongoose is not fully immune to venom, but it will not collapse from a few black mamba strikes. This mutation was identified by Barchan and colleagues. The same molecular solution, with different variants, also found in certain cobra species and several Ophiophagus snakes. But immunity is not the first line of defense. Neural reflex speed, 0.08 seconds. That is the deciding factor. Faster than the black mamba's strike. It reads technical cues from the mamba's body before the attack is completed. These signals appear 80 to 120 milliseconds out, exactly within the mongoose's reflex window. The mamba strikes. First attempt. The mamba cuts through empty air. Second attempt. The mongoose is already somewhere else. The mamba strikes a third time. The mongoose needs no venom to bring down a black mamba. Africa's deadliest snake by fatality rate per bite, reduced to prey by a mongoose 6 times smaller. Somewhere in Kruger National Park, a honey badger is still eating the dangerous cobra it took down that morning. The hyena has gone looking for easier prey. The lion didn't bother to finish it off. Nothing has changed in the attitude of this 12-kilogram animal. 15 animal fight nights, 15 titans, and 15 underdogs. Not every creature is born. Not every creature is born to rule. Some are handed a crown, and others must venture out there to claim it. Only those who go the distance truly understand how heavy the ground beneath their feet can be, and only they truly deserve to wear that crown. The Savanna enters its 5th month of the dry season. Across the Masai Mara, the heat is no longer just weather. It has become a tangible pressure, a physical force weighing heavily on every living creature, draining the very last drop of moisture, narrowing the gap between today and the final hour of existence. The grass has long since withered. Only brittle stalks remain, flattened against the cracked earth, like the bones of a land in its final throes. And in the midst of it all, a lion pride lies beneath the shade of the only remaining acacia tree, within a 2-kilometer radius. In lion society, there is a truth that outward appearances often hide. The male lion with his thick mane, massive build, and a roar that carries up to 8 kilometers is the ultimate symbol of the pride. Yet, symbols alone cannot feed anyone. 90% of a pride's food comes from the females. They are 40% smaller than the males, roughly 70 kilograms lighter, and for that exact reason, they are faster, more enduring, and more agile with every stride of the chase. While the male is busy defending territory and repelling intruders, it is the females who are keeping the pride's heart beating today. That heart must work double time today. The pride's largest lioness stands up as the sun begins to dip toward the west. This is the defining moment. After hours of tracking, the zebra herd finally begins moving toward the eastern watering hole, and the hunters immediately spring into action. The lead lioness stands tall, The others immediately follow suit in absolute silence. Lionesses do not hunt through individual strength. They hunt through coordination, fanning out in different directions, cutting off escape routes, and forcing their prey into critical missteps. The zebras are still drinking as the predatory figures begin to fan out through the grass. The lead lioness locks her eyes on a female zebra standing slightly apart from the herd. That is all it takes. The lead lioness bursts into a full sprint. The zebra herd scatters in chaos, but the targeted female zebra has already had her retreat cut off. She bolts straight ahead, and the lead lioness is already lying in wait up ahead. The hunt concludes just minutes after it began. The pecking order within a lion pride is never random. It is a social system, strictly enforced through power and seniority. Typically, the male is the one to eat first, not because he contributed to the hunt, but because no one is strong enough to stop him. But today, the male lion cannot make it in time. He slowly rises, limping toward the catch. By the time he arrives, the females have already been eating for 15 minutes. They do not yield their ground immediately. They continue to feed, heads buried deep in the catch without looking up even once. This is a rare sight, yet absolutely essential, because the cubs are waiting behind them. If the females do not get their fill, there will be no milk, no strength to hunt tomorrow, and nothing to keep this pride together for another day. Night falls swiftly across the savanna. The entire pride gathers around the catch, with the young ones snuggling tight against their mothers' bellies. The male lion lies apart on the outer edge, his hind legs stretched straight out to take the load off a swollen joint. And with the darkness, a high-pitched cackle begins to echo from the east. Spotted hyenas, creatures that most people often look down on and view as mere scavengers, but that label is completely mistaken. Spotted hyenas are true hunters, and they are by no means mediocre ones. While lionesses hunt using ambush tactics, unleashing a burst of speed over short distances, and concluding the encounter within minutes, then hyenas hunt through sheer endurance. They do not need to outrun their targets. They just need to remain resilient and outlast them. A few miles away from the lion pride, the hyena clan has launched a chase of their own. Hyenas do not rely on ambushes. They charge straight into the open expanse and initiate a long-distance pursuit. Once the distance closes in enough, the entire clan takes turns lunging forward. Two hunting styles, two completely different philosophies, yet they deliver the exact same result on this savanna. There is no single correct tactic. Across the universe, there is only the tactic best suited to the creature utilizing it. Dawn breaks over the Masai Mara. The lion cubs clamber onto their mothers' backs in the early light, as carefree as if nothing had occurred the previous night. And the lead lioness, her old scar catching the morning sun, stands up and sets her gaze toward the horizon. There is no rest period, longer than absolutely necessary, because the zebra herd has already begun to move again. And the pride must secure a meal by this afternoon on this savanna. No one is allowed to merely be a symbol. Everyone must pull their weight. And those who work most quietly are often the ones who keep everything from falling apart. That is the law of the savanna. Mamirawa, Amazonas, Brazil. This is the largest Várzea reserve on Earth, 1.1 million hectares of the Amazon rainforest, spending half the year submerged underwater. Here, water is not just terrain. Water is a predator, and obsidian must learn to utilize it. Shade hunts in the dark. Phantom waits for the rain. Obsidian doesn't need to wait. Because the Amazon never truly sees the light of day. Mamirawa. The canopy is so thick that the sun never truly reaches down to the water's surface. Here, only darkness resides, continuous, eternal, making no distinction between day and night. They do not just operate at night. They are active during the day as well, because here, a black coat provides the ultimate camouflage. But Mamirawa is not the jaguar's exclusive kingdom. Obsidian's adversary has no legs. It possesses 6.3 meters of pure body and 200 kilograms of pure muscle. February 2024, scientists confirmed the green anaconda is not a single species. The southern green anaconda of the Pantanal and the northern green anaconda of the Amazon are two distinct species. The serpent that Obsidian must confront at Mamirawa is the northern green anaconda, a newly discovered species, one that remains shrouded in mystery. Obsidian weighs 90 kilograms. The serpent weighs 200 kilograms. And the serpent is in its element, the water. The anaconda hunts using the environment. It drags its prey into the water, where those 200 kilograms become the ultimate weapon. The serpent's strategy: wait for the adversary to enter its territory, into the gloom of the black water. This is not a tall order. In the Amazon, few animals choose to stay far from water. The massive, slow-moving predator simply waits, just as it has its whole life. Beneath the murky waters of Mamirawa, a 60-kilogram capybara swims. Unaware that a grim fate is waiting. The planet's largest rodent, yet a complete sitting duck before the swamp predator. There is no sound of tearing flesh, only coils of tightly woven muscle. The power of the 7-meter giant serpent lies in its constricting pressure. The anaconda's constriction is equivalent to a semi-truck, pressing down on the prey's chest. This pressure elevates intrathoracic pressure, halting blood flow to the heart and causing circulatory arrest in mere seconds. The anaconda is a titan of muscle, and the black riverbed is its absolute empire. But the Amazon holds more than one tyrant. Back near the dark forest edge, a jet black specter watches, Obsidian. In this world, reptiles are rarely a match for the jaguar, even when they are armed to the teeth. The back skin of the black caiman is protected by osteoderms, bony skin plates as hard as steel. But that goes right out the window. The jaguar's jaws possess the greatest mechanical bite force among the big cats, relative to its size. It does not snap at the throat to suffocate, like leopards or tigers. Obsidian's canines pierce straight through the caiman's bone, destroying the brain lobe and paralyzing the central nervous system. It is over. He vanishes into the brush to enjoy his meal alone. Here, reptiles are prey, not rivals. When capable of bringing down such predators, the jaguar becomes the ultimate apex predator, and no king wishes to limit his territory. The mechanoreceptors on the serpent's skin detect mechanical wavelengths traveling through the water. A massive weight has just entered. It seeks to drive the black jaguar away from its hunting waters. But Obsidian steps into the water, not because he is dragged, by choice. Obsidian is already half submerged in the Varzea current. His specialized fur structure helps him rapidly absorb the water's temperature, balancing his core body heat with the surrounding environment. Obsidian delivers his blow. A thunderous bite drives his skull-crushing jaws into the serpent's coiled frame. The anaconda writhes in agony, its constricting muscles severely damaged. It realizes this predator cannot be subdued. The serpent loses. It does not know that its adversary belonged to this darkness all along. Melanistic jaguars in the Amazon account for a higher percentage than any other jaguar population on Earth. In some areas of the Amazon Varzea, the rate of the mutant melanistic phenotype exceeds 50%. Compare this to the Pantanal, the open flooded plains of Brazil with less canopy cover and more sunlight. The recessive ASIP gene mutation becomes a terminal sentence because it compromises camouflage, rendering the melanistic jaguar virtually non-existent. The same species, the same ancestral gene pool, two distinct pressures of natural selection, two completely opposite outcomes. This is the most concrete evidence of directional selection within the big cat family, not just at the level of theoretical genetics, but at the geographical level. Obsidian is no exception in the Amazon, and that is what sets the Amazon apart from Laikipia and Kabini. Here, the melanistic jaguar does not fight to survive as a minority. Here, they are steadily becoming the dominant majority. The code inside the black coat, predator's ultimate weapon. Look at it. Look closely. Every single leopard has spots, even this one. The spots are still there, beneath the black coat. You cannot see them, but they are there, and that speaks volumes about what hides within each of these black coats. Melanistic. And that gene, for leopards, is not MC1R, as most of us believe. It is the agouti signaling protein, a completely different pigment control system. This is what makes the three shadow predators in this story truly out of this world. Phantom, the black leopard of Kabini, carries the mutant ASIP gene. Obsidian, the black jaguar of the Amazon, carries the mutant MC1R gene. The exact same black, two entirely different genetic systems. But why isn't it common? If the black coat is a weapon, why do only about 11% of leopards on Earth carry it? Because it is a recessive gene. Both parents must carry this allele, and both can look completely normal. Within a leopard population, where 10% of individuals sport a black coat, nearly half of the remaining yellow-spotted leopards carry the hidden black gene inside their bodies. At the very tip of the Malay Peninsula, evolution has revealed its true answer. There, the black coat is no longer rare. Not 10%, nearly 100%. This means that in the right environment, selection pressure is so strong that the recessive allele is no longer rare. With each generation, those carrying the black coat have a higher survival rate. There are more of them. They have more offspring as well. And after thousands of years, the yellow coat becomes the exception. The male leopard chasing phantom through Kabini. The female leopard contesting territory with shade in Laikipia might be carrying that very same gene, and they will never know. Beneath the midday Kabini sun, phantom feels that intense heat. Hotter, more exposed, hungrier. This is the bargain struck by evolution. I give you darkness, but it comes at a price, light. In the savage kingdom, there are no referees, no rules, no mercy. Only two outcomes exist: survival, or becoming the means of another's survival. Survival pressure has forged the greatest survivors on Earth. Tell us your favorite species from tonight's 15 fights in the comments. We read every single one. And don't forget to like, subscribe, and hit the notification bell so you don't miss the most intense battles in the next episode.